Solving a distance, rate, time problem using a linear equation. Two trains leave the station at the same time, one heading west and another heading east. The westbound train travels at 75 miles per hour. The eastbound train travels 65 miles per hour. How long will it take for the two trains to be 252 miles apart? Usually with these distance, rate, time problems, it's best to read the problem over and over again and start collecting the data. Collect the data and organize it in a chart. Make a chart with 2 rows and 4 columns. So let's start with 2 rows. I need a first column to label the kind of trains we have. I said 2 rows, excuse me. Did I say 2 rows? Let's make it 3 rows. And here, this is D. Let me erase part of this. Let me see, partial. Yeah. Let me erase some of this. So I could put an equal sign right there. D equals R times T. In fact, let's erase this part. Let's put a dot here. And put a T there for time, right? Distance equals rate times time. Now what we're going to do is label one of our trains to be westbound and the other one is eastbound. If you want to, you could draw a picture. So let's say our station is a dot. A station could be the origin. And we have one arrow. Which arrow is bigger? The arrow going west is bigger. And then we have another arrow going this way. The train going this way is a little bit shorter. How do I know the one going west is bigger? Because it's actually 75 miles per hour. And the one in blue is a little bit shorter because it's 65 miles per hour. Now, if you envision a train at the end, I'm not very good at drawing trains. I'll try my best here, but I apologize for such a terrible picture. There's a train, some smoke, okay? So there's the westbound train, and we could draw a similar eastbound train. This looks like a broken iron, but just pretend it's a train, and the smoke going this way. Now we want to know, how long will it take for this distance to be 252 miles. Let's collect data, and like I said before, if you need to, read the problem many times. All right, westbound has a rate of 75 miles per hour. So I labeled that in red. 75 goes here. Eastbound, 65. The distance, we don't know the total distance for the westbound, and we don't know the total time either. In fact, that's what we're trying to find. We do know that they're traveling under a common stopwatch. Okay, so they are being started and stopped with a common stopwatch. So just for knowing that, I am going to put a capital T here. Let's put a capital T here. And that is going to be a common time for both trains. Now we don't know the distance though. So why do I call this D1? And why don't we call this, what other color should I use? D2. How long will it take? Let's read. How long will it take for the two trains to be 252 miles apart? We want to solve for capital T. So what do we have here? We have D1 is equal to 75 times T. And we also have D2 D2 is equal to 65 times T. What other information do we know? What's the total distance? In other words, what's D1 plus D2? We know that is equal to 252. That's a good piece of information. Well, now we could simply substitute. Substitute there. Substitute there. And we get 75T plus 65T is equal to 252. That's 140T is now equal to 252. Divide the entire size by 140. And what do we get? We get T is equal to something over 70 here. 252 divided by 2, so 126. Let's divide by 2 again. 63 over 35. And we reduce by 7. So now we have 9 over 5. There we go. And that, of course, is labeled in hours. Let's figure out what that is. The time it would take for the two trains to be 252 miles apart would be 1 4/5 hours. 1 4/5 hours. Now, if you wanted to convert that into minutes, you would say 1 hour and let's divide 60 divided by 5, which is 12, and then 12 times 4, which is 48 minutes. So 1 hour and 48 minutes.